Hello and good morning. We're in day 10 of EOC practice and we're in week 7. Remember, your EOC is coming up 5:17 and 5:18. Okay, so make sure you're preparing and show work. Let's take a look here at this problem. Well, let me think about this a minute. It says that which statement is valid when a circumscribed circle of an obtuse triangle is constructed. Well, if we draw a circle and then we put an obtuse triangle in here, obtuse means bigger than 90 but less than 180. Okay? The longest side of the triangle lies on the diameter. Well, if you make it a triangle like this, the longest side would not be the diameter. So we'll scratch that one out. The circle is drawn inside the triangle, touching all three sides. The circle is drawn inside. Now, this one is circumscribed, so that would be about the triangle. So that would be a no. The center of the circle is in the interior of the triangle. Well, here's the center of the circle, and it's on the triangle, so that would be a no. The vertices of the triangle lie on the circle. Well, let me think about that. Can we draw it like this, where you have it obtuse like that? Bigger. Okay? So in that case, you could have all the vertices on the circle. That's the one I'm going to go with. Okay, now to work the next problems here, if you look at the answers, they're in pi. So that's in radian. So you got to memorize two things. So put a star by this. It's either 180 over pi or pi over 180. Okay, so if you look here, it says, what's the area of the sector of MTN? Well, the area of a circle is pi radius squared. Okay, but this is a fraction. Remember, this is a central angle, so that's 42, the same measure as this. So it's 42 out of 360 degrees. The radius is 8, so that's going to be 8 times 8. So it's 42 times pi times 8 times 8, and then divide it by 360. Let's see what that works out to be, and let's leave it as pi. So 8 times 8 is 64. Get your calculators out. So 64 times 42, press equals, divide by 360. I get 7.466. Now, 7.46 repeating pi is what I get. All right, and so we're looking for something that's going to be that. So we're going to take 53 divided by 180. So 53 divided by 180, and I get something different. 28. Let's try this one. Let's try 112 divided by 15. See if that gives it to us. And there it is. 7.46 repeating. That's our answer. So remember, area of the circle is a fraction of the whole circle. The area of a circle is pi radius squared. Those are pretty easy. Let's take a look at this one here. Okay, so they give us the measure of PZR. So PZR is this one here. Now this one is in radian measure, so we're going to convert it. So put 2 pi over 3, and we want to get rid of that pi, so put 180 over pi. Therefore, the pi's cancel. So it's 2 times 180, which is 360, divided by 3. So that's a 120-degree angle. Okay, now, it says what's the length of PR? In other words, how long is this? The measure is 120. But they don't want that. They want to know how long it is. So all the way around is called circumference. So you want to use pi times diameter, but it's a fraction. So it's 120 over 360. There's the fraction. The diameter would be 8 plus 8, so that would be 16. So you're going to take 16 times 120, press equals, divide by 360. In this case, I get 5.3. So I'm looking for 5.3. Let's try 16, this last one, divided by 3. And we get 5.3. That's the answer right there. There it is. And that's how you do it. Okay? Make sure you know how to do arc, length, and area of a sector. Let's go to the next page here. Okay, so this one right here, let me think about it. In the diagram below, the circle shown has a radius of 10, and the angle B intercepts at 2 pi. The length of this, how long this is 2 pi. They want to know the measure of angle B. What's the angle? Well, the length, let me think about this a minute. I think this is a work backwards problem. So we're going to take pi times diameter, and it's a fraction of that, okay, equals the arc length, which they say is 2 pi. Okay, so how long it is right here. Now this is going to be a fraction of the whole circle. So we don't know the angle. That's what we're looking for. So we're going to put an X right here for the angle. It's a fraction out of 360. So it's the angle divided by 360. Let's see if this works. Now, we know that the diameter is 10 plus 10, so that's going to be 20. So it's going to be X divided by 360, because we don't know the angle measure, right? And then that's going to be pi times 20, the diameter, and then equals 2 pi. Okay, so what we're going to do is draw a line. We're going to divide both sides by pi, and when we do, the pi's cancel. Okay, so let's see what else happens. We're going to multiply by 360 and then divide by 20. Let's see if that works. So 2 times 360, press equals, and then divide by 20. I get 36 on that. Now let's see. 36 degrees. Let's see if that works. So 36 over 360 equals pi times diameter, or times pi times diameter. Okay? So we know the diameter is 20. So it's going to be 36 times pi times the diameter, which would be 20, divided by 360. Let's see what that works out to be. See if that gives us 2 pi. So it's going to be 36 times 20, press equals, divide by 360. And that gives us 2 pi. So that does work. Okay, so we're going to get 36 on that one. Now, let's think about this a minute. Let's change this 36 degrees to radian measure. So put pi over 180. Okay? So basically we're going to get 36 divided by 180. And I get 0.2. 0.2 pi. 0.2 pi. Okay, so now let me think. 0.2 pi is 2 over 10, which is 1/5. So that's going to be times pi. So that's going to be 1/5 pi. Okay? So on this one, I get this. That is 1/5. Okay, so I had to do a little bit of thinking there. I had to work backwards to get the angle. They gave me the length. So I took the fraction, the angle, which we don't know, divided by 360 times pi times diameter equals 2 pi. I divided it by pi, pi is canceled. I multiplied 2 times the 360, and then I divided by that 20. And then there, I got 36, but then I changed it to radian measure, which looks like the answer choices. So I used pi over 180, and I got 0.2, which is 2 over 10, which is 1/5. So that one actually required a lot of little work there. Let's go to the next one. An arc of a circle has a radius of 10. So we're going to say the radius is 10. Okay? And then it's going to be the arc length right here. How long this is going to be 49 pi over 9 is what they tell us. What is the measure of the corresponding angle? They want to know this first. It's a two-part question. What is the measure of the corresponding angle? Central angle. Okay, so this is the same thing. So it's going to be some fraction. So we don't know the angle, so it's x over 360 times pi times diameter. The diameter is going to be 20 equals the arc length, which is 49 pi over 9. This is a work backwards problem, so we got to do it again. So we're going to divide by pi, get that canceled, and when we divide over here, it cancels there. We're going to multiply times 36, and then divide by 20. But we also have to divide by that 9. So let's do this right now. 360 times 49, press equals, divide by 20, and then divide by 9. Okay, I get 98, and that is correct. So it's 98 degrees. Okay, so 98 degrees is correct. Now, it says if the radius is reduced to 2, is the arc length of 49 pi over 9 still possible? Well, let me think about that. If the radius is reduced to 2, then the diameter would be 4. And you're using the same thing. So you got to work that one again, and I'm going to use a sheet of paper. So watch what I do and pay attention. All right, so now I'm going to take a fraction, which we don't know. We're going to try to work it the same way. So it's going to be a fraction over 360 times pi times the diameter is equal to 49 pi over 9. Is it still possible? Well, I'm going to divide by pi, just like I did before. Pi is canceled. So I get 4. I'm going to multiply by 36, or 360, and then divide by 4. So 49 times 360, press equals, divide by 4, press equals, divide by 9, press equals, and I get 490. So the answer is no, it's not possible. Okay? Because it's bigger than 360. All right, let's keep moving. Number 5. If the area of the shaded part is that, what's the value of x? Okay, so it's going to be the area of the sector is pi radius squared times some fraction, 60 in this case over 360, is equal to, and then they're giving us the area, or, yeah, so we're going to have 15 pi, and I have that backwards, but that's okay. Okay, so now we're trying to find the radius, which is x. So now to do this, I'm going to divide by pi, just to get rid of it. Cancel, cancel, cancel. I'm going to multiply 15 times 360, and then divide by 60. So let's try that. So 15 times 360, press equals, divide by 60, press equals, divide by 2, press equals. I get 45. So I get r squared is equal to 45. Now let me think here a minute. Let me make sure I have all of this right. Okay, so the equation is set up correctly, but 60 represents the white part. We don't want that. That should be 300. So scratch that out and understand they want this, which is 300 degrees, because 300 plus 60 is 360. So let's rethink. We have it set up correctly. We're going to multiply by 15 times 360, just like we did before. Press equals, but only this time we have to divide by 300. Press equals, and then divide by 2. Okay, so you get 9. So the radius squared is equal to 9, and then to get rid of that, you got to do the square root. And the square root of 9 is 3. So the radius is 3. These are a little tricky. This one right here is dealing with concentrics. We didn't really talk about that. I'm going to let that one go for now. This is page 2. Okay, so now we got to do page 3 and 4. And I'm having to use my printer today, and these are taking some time here. So I think we're going to stop right there. Have a good morning.